Well, hi, good morning. Thanks so much for joining me in my shop here, keeping me company while I work away on this radio. Today is November 13th, and so I had a plan in mind. And just before I started the video here, I thought I'd just check it a little bit, and I no longer have that plan in mind. So here's what's happened. Replaced all the obvious paper capacitors, so now it's a question about a few others. These black ones up here, and there's quite a few of them tucked down below. A bit of a question around those, especially this one with a cracked shell on it. And then some questions around previous work done. There's a capacitor in here that's been changed. There's a new one in here. And I think maybe that's the only one. Tucked down in here, maybe a new resistor with it right here too. So my plan was this. It was a good plan. I would take this cracked one out, replace it, and test this outside the radio, find it bad, make a judgment about whether I should change these others. My experience with these black capacitors has been good, actually. I find them to be good. And I've learned from experience it's better to not rush in, it's better to take your time in situations like this and not jump at something. Just realized there's another one of these black ones down here too. So I thought, well, why don't I measure these in circuit? This little tester here has some capabilities of doing that. So the first one I'm testing is I'm just going to double check here. 5600 picofarads with a cracked shell. 5800, zero loss. 56, 58, wow, that's close. So I went on and I tested the rest of them here that I can get at fairly easily. This one I think is a 2400. 2387. It just doesn't get much closer. And so it is with all of these. Except this one, I didn't test this one. All the ones I can easily get at, I don't have to dig for. They all show up correct. So at this point, I just have no reason to replace this other than the visual fact that it's cracked on the shell. But its operation seems fine. So I'm not going to do that. Instead, change the plan. I'm going to look more deeply into this capacitor here that's hidden a little bit. This one right here, this black one. So the value on it I can read. The guy was nice enough to install it so you can read the value. 0.0047. So that's 0.005. My preliminary investigation says that should be a 0.01. Preliminary meaning I've checked into it and I don't feel comfortable with. I think I may have identified the wrong capacitor or something like that. A 0.01 would be probably a paper capacitor, and that would be attractive to replace, and maybe that's why this got replaced. There was a paper one here. Why did he replace it with a 0.005? 0.005, 0.01, that's a significant difference there. Is it in the right position, or is anything right about it? What about this big fat high wattage resistor? You don't normally see high wattage resistors in the radio like this. You can see it right there. So that's what I want to look into more deeply now. And I'm going to start by studying on my own and trying to get a good feel for just where this guy's connected. It's very hard to see up in there. Onward. Well, so far what I'm concluding is this has been done incorrectly. Not only is it the wrong size capacitor, but it's not actually in the right position. How correct am I? So in this kind of situation where I'm having doubts with what's in the radio, if it's from the factory, I really doubt myself, and I almost always find out, yeah, I got it wrong. But when someone else has done it, they've got just as good a chance as me of getting things wrong here. So here's my diagram. We're looking at C9 and R2. So R2 is a resistor that's connected to a terminal on, I think this is the oscillator coil here. I think they call it the detector coil, in fact. Not the oscillator coil, it's called the detector coil. Here. And the other end of this resistor goes down to a terminal strip with 3 terminals on it and a ground lug not connected. Well, that's exactly what I see. This resistor is tied to the end of a terminal strip. There's a ground rivet here, and then there's 2 more terminals with wires on them. So I think this resistor is connected to the right place. And that's way down here. Way down here. Yeah. Can you see that? No, you can't see that. My hand's in the way. We'll look with the close-up camera here and verify all this stuff because it's not adding up properly. Oh, I don't have that camera available. Oops. Okay, ready now. So we're going to be putting the camera right in here, looking right down in this area here. Okay, concentrating on the resistor and where it goes. Down at the back there. So pretty clear it's connecting to that terminal with the red wire. That terminal at the terminal strip, there you can see the ground lug and then the 2 more terminals. The ground rivet there in between. So that's absolutely correct. Now, what about the size of this resistor? It looks like something black-orange. Get a little more light on it here. It looked like orange, black, orange to me. What else could it be? Well, that would be 30, that'd be 30K. And I don't know what the value should be offhand. I think that's R2. I have to do a little more looking. So I think it's 30K. So let's look at the capacitor now. Well, let's do this first. We'll take a look on here. So you see R2. The one wire goes to, we didn't check that. The other wire, the lower wire off of R2 is coming over to this terminal strip. And you can see how they've done it there, lug and the 2 other wires and a red wire coming off it. So there's no question that that's R2. Now, from the same other terminal, we'll follow the other terminal, which is on this coil. We should find C9 connected on the coil side. Okay, so I think this is correct. Now that I look at it, I'm thinking to myself, well, how could he make a mistake here and have this radio work? So the coil connection from the resistor is you got to follow the lead. It's not easy to follow. Coming off the resistor. Heading back to that terminal on the coil. And the capacitor is connected from the coil terminal, that's where it is, down to the tube pin. Must have been fun soldering that down there. And that tube pin, if you look, you can see the key on the tube key. So that's number 1. That's pin number 1. Come over here. Pin number 2, hard to see. Pin number 3. They're all tied together. That's exactly how they are on the schematic here. If we look, we see C9 from the coil side of R2. So the thing is, in the radio, the wires are running the other direction. You have to flip this around a little bit. So C9 tied from pin number L10 on the coil, and then tied to this strip of grounded terminals. It is C9 and R2. What are the values for C9 and R2? Okay, so we're looking for C9. Well, there it is right there. 0.01. 0.01, but what's in here really is a 0.005. So it's half the size what it should be. Its job is to ground out something, ground out some signals here. Bigger would be better, not smaller. Okay, it may only be playing a role on certain bands. We really have to study this these are the oscillator coils here. Because of that darn switch there, I think it's pretty complicated. So there we are anyway, and then here's the resistor right there, R2, 1,000 ohms. I don't think that's a 1,000 ohm resistor there. Can we measure it? Where does it go? So one side, it's going all over the place. Going everywhere. Might be able to measure it. It's going places, but those places don't go anywhere. Plate circuits. We might be able to measure that in place. I'm lost. I'm just wandering around. Here we are. It's definitely 1,000 ohms. Wow, that third band really looks orange to me. Let's see if we can get the meter on it. Try this one first. The problem is connecting to the lower wire. I got it. I got it just like that. Huh. 108 ohms. How do you get 108 ohms on that? So 100 ohms would be brown, black, brown. That's probably what that is. That's probably brown, black, brown, but it looks like orange to me. Why the huge wattage resistor in there? Is this a busy resistor? Is it a hard working guy? It's a little small on the camera. There. Wouldn't imagine it to be a hard-working resistor. And amongst all these coils. Certainly doesn't say anything. R2. I think there's a parts list. I'm going to take a look at the parts list here. Let's read it again. .100 ohms, supposed to be 1,000 ohms. And the capacitor is supposed to be, the resistor should be bigger, the capacitor should be smaller, bigger also. So I think this qualifies as probably a junk box repair, where somebody did not have an extensive set of parts, and they just made do with what they've got. And that's what they ended up with. They stuck it in, and hey, radio started working. Before that, it may not have been working. If this resistor were open or something wrong there, maybe it wasn't working at all. Maybe. So the problem is they have no judgment. It starts working. Hey, that's great. It's working. Is it working well? Is it working like it should? That's hard to know. That's a tricky question. And my question is, what should I do? Should I get in there and change these guys? I think I should. But I'm going to go and take a little break before I decide what to do there. Remember, there's a risk with everything you do. Stuff goes wrong. Certainly in my shop, stuff goes wrong. Well, let's take a closer look at what these two components are doing, and maybe that'll help me decide what I should do about them. So here they are here, right here. Kind of odd that they're both replaced. Might suggest that this original capacitor shorted out, and then too much power went through this 1000 ohm resistor and burned it. It's common for capacitors in these old radios to short, cause a heavy current, which then subsequently damages some other part, like a resistor, or even a coil, which is a disaster. It should burn out a coil. Occasionally, radio designers place resistors in places where the resistor will act as a fuse. So they maybe said here, boy, if this guy shorts out, then it's going to draw current through these coils and burn them out. So instead, we'll stick a resistor here that will give up the ghost before the coils do, and will act as a fuse. Maybe that's what was going on here. The 1000 value is suspicious because 1000 ohms is an easy number to calculate against. So if you have a volt dropping across a 1000 ohm resistor, you know it's a milliamp of current. So sometimes these 1000 ohm resistors are in these radios to offer an opportunity for people like me to make a judgment as to how much current is flowing in a circuit. The 1000 ohms itself not having much effect on anything otherwise. It's just like a shunt, an ammeter shunt. Why this one is here, we don't know for sure. I mean, another reason for a small resistor is to provide some degree of isolation between 2 points in a circuit. Another one is, especially in grid circuits, to snuff out oscillations or to make oscillations less likely. So I don't really know why they picked 1000 and stuck it here. Let's just keep going. We'll see if we can figure it out. So a fairly large capacitor tied to the chassis is trying, in most cases anyway, to provide a signal ground to this. It would be this point in this circuit. Let's just trace these wires back and see where they go. So we have a primary, A band, primary, A, B. So the different bands. 31, 25, 19, A primary, and A. So is this the A secondary here? Probably is. Probably this is the secondary side. They just didn't put the word there. All these coils here, and the switch here that's selecting them, are setting up the local oscillator frequency. So now, is this involved all the time? No matter where you set the switch? Yikes. Let's go up to the, oh, this is the other part of the switch here. Yikes. These switches, they destroy me. I have a heck of a time sorting out what's what. I mean, it takes a lot of effort. You have to make a lot of diagrams. And, mentally set each switch and then trace away where things are going. I'm not about to do that. I don't think I need to do that yet anyway. I think we can sort something out here. So there's an interesting thing right there. This dotted line, this one, says through connection. So it's telling you that this switch is connected to this switch electrically. And now there's another dotted line here. Through connection. Okay, yeah. Well, I guess it's the same sort of thing. How can it be? It stops here. I just don't know what they're trying to show here with this dotted line. So we're not really getting anywhere yet. So if we go over to the 6SA7, we look at the grid, follow the grid back. There's a big resistor there, 500,000 ohms. Signals coming through here. All signals pass through this capacitor. We got some direct connection here. And we're working our way up to the primary side. Look at that, there's a relationship here between all this stuff. So I've just followed wires, and there's no switch involved here. So no matter where you set that band switch, this switch and this one, this connection is maintained. So that tells me these guys are doing something all the time. I can figure out more closely what they're doing. So if this is the signal grid, which it is, the signal grid is hooked up here. Surely to goodness the A band coils aren't operating all the time. I think if we follow back this way through this capacitor, we see it going the switch. This looks like this is the connection to the band here. Oh, I hate these switches. There's little tiny arrows there. God, if you're not watching this on a big screen, good luck. Okay, here we are again. Following the switch here. It's just selecting all these different coils. Except this connection's always hooked up. Well, it would strike me that these are going to affect all the bands. Maybe mostly the A band, perhaps, but it looks like you get these wrong, you might be upsetting the whole radio in some way. Now, what if you put in too big a resistor here? No, too small a resistor. 1/10 the intended size. It's assuming I took a proper reading there. Brown, black, brown. Well, I don't think it's good to go to 1/10. You're going to have 10 times the current flow through here. And it's pulling signal current anyway, no DC through here, but signal current through these coils. I'm probably not going to burn anything out, but you would disturb these a lot. I think so a certain amount of current flow through this resistor will build up a certain voltage across it. The voltage, if you put 100 here, will be 1/10 what it was intended to be. They have 1/10 happening here. It just doesn't sound good. And what's going on up here? This is a plate connection. Uh-oh, let's look a little closer here. Plate connection means there's high DC voltage here. High DC voltage here. Where's it getting its voltage from? It's getting its voltage through this resistor. Back here, here's another line going up. That's connecting to a plate. So this is a voltage source. That's what this is. This is a decoupler. The idea is you're bringing high voltage to each tube, a couple hundred volts, 300 volts, whatever it might be. You're doing it out of one power supply. Well, you just can't hook that wire straight up to all the tubes. The tubes will be feeding signals to each other. So you need to somehow isolate them away in each case a little bit. I think this is probably an isolation. I think that's probably the purpose of it, and it could well be that current thing too. Just by peeking at the voltage drop on here, perhaps. So we have DC going through here, through this coil. Yikes! If you drop this to a tenth, you'd have to think there's more, like to 100 ohms. You have to think there's more current going through here. And you'd be pulling more current through the plate, through this whole tube. So throw this whole tube off. And you're going to supply more plate voltage. I tested the plate voltages on these tubes, did I not? I don't know if I took the time to write it down, the values. I think I found them all to be pretty normal. Where's the table? Here's the table of values. I didn't write them down, of course. But I found them all to be fairly normal. This tube is supposed to have 210 on it. I remember it was right around that range anyway, I'm pretty sure. So maybe this isn't having as big effect as I think. So now there's lots of reasons to make sure this is really 1,000 here and not 100. Now what would happen if this guy shorted? So if this guy shorted to ground, you'd have a short right on this line here. If we go back, did I skip lines there? Make sure I'm following the right line. Okay, this is the right line here. Here we are. Another takeoff. This is at 10,000 ohm. A resistor. Come back here. This is going up to power the screen grid and the plate on the output tube. So it's a pretty important line here. Come down here, right to the power supply. Well, there's nothing restricting the current coming out of the power supply traveling down to that resistor. So you can almost bet that if this failed and shorted out, this would burn shortly afterwards. The original resistor is not a big wattage one like what you see in there, and that might be why there's a higher wattage one. The fellow doing this may have reasoned that better put a bigger wattage resistor in here. He might have defeated part of the purpose of this, which is to burn out if, under the worst cases. Although if this shorts, it's not pulling current through any coils. Not that I can see here. Just through this resistor. That's probably the story. This guy probably shorted, the resistor burned out, and the last guy found it, reached in his junk box, couldn't find 1,000, or wanted a larger wattage resistor, and the best he could do is what he got, 100. Oh, he should have been nervous doing it. And then here, you put in a smaller capacitor, which would only, I would think it's not going to improve things, that's for sure. If you put a bigger one in here, you might do better with this radio. A smaller one, I don't think there's any doubt. I need to change these two and bring them into the normalized values here. I don't think there's any doubt. You might wonder, well, if it's got those values on the schematic, surely you should follow them. And yeah, surely. If your name's Shirley, sure, you should. But when you find something done by somebody else, it's a couple possibilities. One is it's the best they could do. Another one is they didn't know what they were doing and they did something really stupid. Or that's all they had. All they had available. Today it's an easy thing to get on the internet, order some capacitors. They're in your mailbox a few days later. It's an easy thing, but 25 years ago, I have to go back a fair ways now, not so easy. So the tendency to use junk box parts is much, much higher. that's almost certainly the story here. So I'm going to change these back to their normal size. As much a hassle as it is working in this little space here, that's what I'm going to do. Jeepers, should we look for changes in the radio's behavior? Yeah, I think we should. So I got to think about how to set this up so we can detect a change after doing this work, like a before and after test. Okay, I think I'm ready to go here. What I've done is I brought out another vacuum tube voltmeter. So this guy is going to be reading the plate voltage on the tube that receives the tube that's beyond the 100 or 1000 ohm resistor. It's still the original resistor in here. Let's just zero this meter up. Okay, and it's set to DC volts positive, 500 volts full scale. This one continues to read the AVC voltage. Got my signal generator ready to feed a sort of regular antenna signal into the antenna. We're going to do this on the A band, which is the broadcast band. Let me just put the radio there now. There we are. We're on the A band. Volume down. Tone somewhere fairly high. We're all set. So first thing is get the radio receiving that. Read the plate voltage and the AVC just for interest. It's a plate voltage I'm really interested in. Fiddle with the radio a little bit, see what happens, and then change those two parts and repeat the test and see what happens to the plate voltage. Plate voltage on that tube is supposed to be 210 on pin 8. Okay, we're all set here. Very sure. Just making double sure. Did I plug it in? Yes, it's still plugged in. Okay, we got everything banging up here. Antenna shorted? No. Okay, I think we can turn it on. There it goes. Dim bulbs behaving normally behind the antenna there. There's the plate voltage. That's 450. Climbed up to 450 volts. Wow, that's why you need a lot of good capacitors. Now it's down around 150. 150, and it's supposed to be higher. It's supposed to be... Oh, we don't have it on full voltage here. Don't make that mistake. That's a better move there. Okay, so we should be seeing 210, and on here we're seeing 260, if you believe my meter. Meanwhile, this guy's going the wrong way because I don't have it on negative. This is on the 50 volt scale, so it's about 6 volts of action there. Now I've got to tune my signal generator. Well, I'm not hearing anything. Why are we not hearing anything? Oh. Hey, it's working better now. I didn't do anything, did I? Just talked about it. Okay, so that's probably 590. I'm going to want this to be up where there's nothing. What's going on? The string's not moving. I think the radio's pinching one of the wheels. Okay, I gotta watch the AVC meter here. We want the AVC meter as low as we can get it. That looks like that's about as low there. I have the feeling the tuning knob is not driving the tuning very well. Okay, I'm going to tune the signal generator till we hear it. Up on the signal generator output. Okay, we're up around 730 is where the radio's tuned. So we should be looking for the AVC voltage to go up. Let me just give this a real good shot here. You can see the AVC went up a little bit. I'm going to put this meter on a more sensitive setting. tuning the signal generator. And watching the plate voltage. It rises up as we tune in. Why exactly? I don't know. So there we have it. Nicely tuned. And I want to make some notes. Here. Okay, so the plate voltage is way high, isn't it? The chart here. Should be 210. Make sure you look at the right meter. It should be 210. But on here it's 275. Now I'm going to double check this with my other meter just to be sure. And I calibrated all my meters in here, but I don't use this one very often, so let's just double check. Ground to here. 273. And on here it's 273. Could be. Okay, so my BTVM is on the money. Thought it was worth double checking that before trying to make judgments about things. So the number that I write on the page here is 275. $275 with a small resistor there. Wow, we don't expect it to go up from there, right? What's another one that should have, like I should find on pin 3 of the 6SA7, that's this tube, I should find 220. Let's take a look, see what we find. Okay, watch out, hot clip lead here. Pin number 3 on there. Okay, 1, 2, 3. Scared myself. Similar voltage, 270. So the B plus is high throughout the radio. Why would that be? We are feeding the radio with a regular 115 volts. I don't know. It's high. It's a little high. Well, one possibility is this coil has not come from this radio. This does not get hot, by the way. I've checked that previously. Maybe that's from another speaker. Maybe it's not the right size coil. Don't have much other explanation for why the B plus would be high, but we can look into that later. The point is, it's 275. Let's hook this back up. And it's still 275. Okay, now I'm going to change those parts, and we're going to just repeat this. Did I write the ABC voltage down? I did not. Better do that. So on the 15 volt scale, 11 volts. 11 volts ABC. Okay, power off. Let this sit for a couple of minutes, drink some coffee, change those parts, and then we'll see what we've got. It's so tight in here, I decided to take out this plate, get it out of the way, because it's very low risk removing this and putting it back. That's going to give me a lot more room to work in here. In fact, I'm not sure it can be done without about doing that. I've already cut free the resistor and the capacitor, and I've left a bit of the lead back here in case I need it. Very, very solidly done. I think I'm going to cut this capacitor out. .0047. Now this resistor. Maybe I can desolder that. A lot of solder here. Come on, soldering iron. I want to desolder. Just got it there, I think. There it goes. Come on out of there. There it is. Brown, black, brown. That's what that is. That's a 100. Where you're supposed to have 1,000. Okay, let's just give this capacitor a check here. See what we got. If it's a junk box part, there's a chance it came out of another radio. It was not new before going in there. Feel guilty every time I use one of these. So that's 5,000 picofarads, 0.005. Exactly what it is. It's not what it's supposed to be. It's supposed to be 0.01. Okay, I'm going to fish out some parts. I'm certainly not going to put in a high wattage resistor. It's not needed. We'll put in the parts that are needed there. Okay, I've got the new capacitor and resistor in there. Okay, looks good. Now, which way did this plate go? Is it this way or that way? And the other screw. There it is. Okay, looks good. There we go. So this plate is preventing this coil from affecting this coil right next to it. That's what the plate is there for. Okay, I think we're ready for another test. Okay, so I've left everything operating here. Let me just turn off my soldering iron. Better. It's a lot better on the meters. Okay, so this guy was measuring the B plus, which was right up here. Get my tools out of here. Too much in front of my eyes. Get this danger solder out of here. Okay, got myself a 100 ohm resistor, high wattage resistor. We're all set here. Okay, now we're going to rely on the dim bulbs. I fooled around with the B plus circuit. Mind you, I don't think what I did would result in a full-blown bright dim bulb. It wouldn't be dim. Okay, no smoke coming forth. That's good. What do we got? We got voltage up here. We got voltage here. Okay, let's put it on full. I hear a little bit. So now this is risen right up to the same place, 275 B plus. And this guy's up around 11. Isn't that higher? No, 11. It's the very same. This indicates a signal strength coming from the signal generator. So it didn't make any difference on those fronts. Okay, so what we'll do is we're going to just tune something in. See if we can hear any difference there. Very sensitive radio. This is the antenna ground. This is the antenna. Turn it down just a wee bit in case. And you know what? This is not switched on here. I have to run through my house and switch on this antenna, which I will do. That doesn't sound much different to me. Okay, now we're going to tune down to where pick some stuff up before. So that's 590 sports channel. Looking for 640 and 680. They're not going to show up. Let's just keep going. Nobody else coming in. It's a French station right around this area. Not showing up. That's fine. It could be the antenna's not aimed in the right direction. It's just lousy the way things are set up, and that's why we can't get it at this point. So I'm pretty happy with the situation now, capacitor-wise and the like. I'm really intent on leaving these alone. I don't think there's any percentage benefit in fooling with them and some risk involved. And that's a good thing because a lot of them are down deep under here, hard to get to. The next step with this radio will be to do an alignment and then assess its performance at that point as to whether it really needs more attention or not. I still have to deal with the power supply hum, which is easy to deal with. I'm just saving that. Saving that for down the road. So that's great. So thanks for watching that today. And tomorrow I think we'll work on the alignment tomorrow. Just remember to turn this off before you forget. Okay, see you tomorrow.